Welcome to lesson 5.5, where we are going to do some more optimization problems. We only have one example for this lesson, and it's actually a little similar to what we did last time. So I'm going to start the same way, where I'm going to get you started, and then I want you to try to apply the concepts from 5.4 to this problem to finish it on your own. So let's read the problem. The sum of two non-negative numbers is 30. Now let's pause for a second and focus on this word right here. Because in the second video of the last lesson, it talked about the product of two positive numbers. So what is the difference between saying it's positive and saying it's non-negative? The difference is including zero. Non-negative includes 0. Positive does not. That will be important for the answer for this problem. So the sum of two non-negative numbers is 30. So let's say sum of two, let's use A and B, non-negative numbers is 30. Now, find both numbers if the sum of twice the first plus the square of the second is a maximum. So let's just say it equals C, and we want to maximize it. So this is the equation I'm going to take the derivative of, because this is what I want to maximize. And remember, you need to have one variable on each side. So we're going to have to use this and substitute things in to get to that point. And then we can take the derivative, test the number line, all that good stuff. So at this point, I want you to pause the video, try this one out on your own. Just like we did in the second video in 5.4, I will show both routes to the final answer so that whatever route you take, you will be able to check your answer at the end. Ready, set, go. Let's look at what we've got so far. In this first one, I solved for A and plugged it in. Took the derivative, found the critical numbers, found the critical number to only be 1, no place where it's undefined, and then I started my number line. Now notice my number line has end brackets, because they have to be non-negative, so I can include 0, and the biggest number I can go is up to 30, because they have to add to 30. So I have those brackets here and my critical number. Now notice when I test it out, I get decreasing then increasing, which is not a maximum, it's a minimum. Now let's go over here to the other method. If I solve for B and then plug that in and took the derivative and solved it and got my number line, same thing with those end brackets and plugged it in. Same thing, I get a minimum, not a maximum. I want to maximize this number. Now, at this point, we would normally say, well, there's no maximum, it doesn't exist. But there is a little tricky thing we can do. Now, if you remember back in chapter 3 or 4, when we talked about absolute maximums, and we took all the critical numbers and the endpoints, and we plugged them all in to see which gave us the biggest answer. And whichever answer was the biggest, that was our answer. That was the absolute maximum. So what this is telling us right here is if we want to maximize this, there are no maximums in the middle of the number line. However, we could still test the endpoints. So if we're going to test the endpoints, which we can only do because they are included in the problem. So if this had said positive instead of non-negative, this would be a totally different conversation. We can include 0 so we can test the endpoints. So my first endpoint is if B equals 0 and A equals 30. And my second endpoint is when A equals 30 and A equals 0. So I'm going to test these by plugging it into what I want to maximize. So 2A plus B squared equals C. So 2 times 30 plus 0 squared equals C. So that is going to be 60. Now let's do it over here. So 2 times 0 plus 30 squared equals C. That one's going to be 900. So this is obviously bigger than that, which means those are my numbers that will maximize this answer, give me the biggest answer. So that's it when B is 30 and A is 0. again, I can write this as a sentence. Let's see. If I want to maximize 2a plus b squared with a plus b equaling 30, then b should be 30 and a should be 0. And then, well, that's our answer. So that is it for your optimization problems. You should be able to do your homework and your quizzes now.